Whether you're dealing with national defense, energy infrastructure, climate, or the environment, one fast advancing technology is helping: autonomous and unmanned systems. Welcome and thanks for joining us. My guest today is Tim Saffold, the Executive Vice President of Autonomous and Unmanned Systems for the Engineering, Science, and Technology Strategic Business at Amentum. Tim, it's good to have you with us.
Thank you, Tom. Appreciate it. Very good to be here.
And we're going to start with the idea of unmanned systems in national defense. And national defense takes place both in the homeland and around the world. So maybe give us an overview of how these systems are helping and what roles are they contributing to in national defense?
Yes, absolutely. So, we could do a history lesson, go back to, we can go way back, but let's start back in the 90s where we see the advent of some of the complex and most sophisticated unmanned systems called remotely piloted aircraft. And they're operating in various theaters of operation that everyone has seen in the media and the press. And the traditional roles of this system has been pretty much intelligence, surveillance, and reconnaissance, gathering information that support the various services and the missions that they need to accomplish. And then we see them evolve into a strike platform where they can deliver kinetic effects. So where we're going today is more of a collaborative approach where you see these systems starting to work together. You see them working with manned platforms as well as other unmanned platforms. And what the vision is we're moving more toward a real autonomous capability where you're not just a rules-based prescriptive algorithm where you're telling the system what to do, but the system can start to think for itself. It can start to interact with other systems. It can take data, it can learn from that data, and it will continue to provide decision quality information to the services regardless of whether they're operating outside or within the United States in terms of homeland security in that case.
Because you're making a very subtle distinction there, because the military until now has been reluctant to talk about autonomy, because autonomy means that a fire decision is not made by a human being, which they don't want, because every decision has to be auditable and transparent. So it sounds like some autonomy can come into these systems, but yet the decision may not totally be autonomous, but the reaction, getting to the point that they need to be at, avoiding the other systems, that's where you do need autonomy. So it's the careful application of autonomy to what are now uncrewed. Would that be a good way to describe it?
Tom, that's a great way to describe it, because a fire decision will never be an autonomous decision. I mean, that decision will be made by a human in the loop. Will make that decision there. But there are many tasks that an unmanned system, be it an airborne system, a ground system, or a maritime system, can do things and make decisions on its own that doesn't necessarily need a human in the loop, but a human on the loop. And making sure that the systems are operating the way they're supposed to be operating and conducting themselves in a way that they can gain the most useful information.
Right, so for example, right now you might have to manually guide it to that Toyota in the desert that you want to fire a rocket at. But in the future you could say, find the Toyota, but the decision to fire has already been made by me. Now you have the autonomy to get where you need to go without someone standing there for hours guiding it.
No, that's true. That's true. And also with, it goes beyond that. It goes to sensor applications. When you talk about what is the sensor seeing, what is the sensor looking for, can you program that in such a way that that sensor can not only look for what it needs to look for, but it can communicate with other sensors. Let's say that it has a problem, and it can communicate with another sensor and basically say, I have a problem here, can you pick up the load over there? And perhaps then we can meet mission in that way.
And what about the risks to personnel on the ground? Obviously an unmanned or uncrewed system, you have a safe operator who's probably back in the United States or back in some safe base. But can these systems, and are they being used to better defend personnel on the ground that are in harm's way?
Absolutely, absolutely. I mean, that goes back to being able to gather information that's relevant and very specific to any particular mission or operation that then can be used by both personnel on the ground or other personnel in the air or personnel on the sea, doesn't matter what domain they are operating in, then that way they can take that information and make better decisions which keep them safe and also keep them in position to be able to execute efficiently and effectively.
And what are some of the special considerations for the data that goes back? Because there is a lot of data flowing now between the crew and the uncrewed system, and among the systems themselves now, as you mentioned, they're interacting more, and we're getting toward that swarm idea, I guess, at some point is the dream of the future. But you've really got to protect that data, make sure it doesn't get corrupted. What are some of the considerations in that particular data streaming environment?
Well, the security of the data is absolutely paramount. You don't want the data to be corrupted. You don't want the data to be compromised in any way, shape, or form. But the volume of the data then requires certain technical requirements that allow for that data to get to where it needs to be, and in a format that it can be in where it can actually be assessed. And when it's assessed, then it can be turned into decision quality information at that point. And oftentimes you parse through the data, and this is where, you know, AI may come into play more so in the future as that continues to evolve, to help decide what data is actually relevant, which actually will support that decision quality information that the decision maker needs to have.
All right, let's turn our attention now to the energy infrastructure topic, something else you're concerned with this division. Autonomous unmanned systems are used to monitor and look at and otherwise help in the maintenance and operation of energy critical infrastructure. What does that look like nowadays?
It's exciting. That's been very exciting. And I've had the opportunity, some of my teams have had the opportunity to work in this sector where we've actually done an autonomous mapping of the interior of a chimney stack that supports one of our critical facilities here in the United States. And what we did is designed, engineered an unmanned system, a vertical lift unmanned system that basically could inspect and map the outside of the chimney, but also lower into the chimney a camera device that was spatially oriented in a way that it could basically map the interior of that chimney. And that's without someone putting a hazmat suit on, taking weeks to build scaffolding, pick that person up by a crane, and then lower that person down into the chimney in such a way that they could take a handheld camera and do the inspection. So we're able to, at that time, to do something that turned several months of activity into 3 days of activity, which is very, very promising. That's one area. The other area, you know, we have a lot of linear infrastructure in the United States. We have a lot of, you know, train tracks, we've got power lines, we've got, you know, various facilities there, and unmanned systems can really create the efficiency of the inspection. And my teams have done that before with power lines and that infrastructure, and we've talked a lot with various train transportation companies of how we might do track inspections and those kind of things that not only create efficiencies in terms of time, but it also allows more accurate data and the assimilation of more accurate data over time in such a way that you have an archive that you can make decisions going forward. And if you need to research, you can go back and see where you've been and then make decisions on where you need to go.
I imagine this could really enhance the ability to do, say, proactive pre-maintenance or scheduled maintenance.
Yes.
Instead of waiting till you have to send a crew in the middle of the night, which is expensive and slow.
Yes.
You would just do simply, you know, preventative maintenance on a schedule.
Yes, absolutely, Tom. That it's so important. And then in other areas where you have infrastructure that perhaps has corrosion issues and it's kind of hard, or perhaps it creates unsafe conditions where you are trying to put a person inside that facility to go inspect all these various. And my teams have done this sort of thing where we've used unmanned systems to actually fly in and around the infrastructure, the metal structure, and map the areas that are problems with particular corrosion and that sort of thing. So that's another area that's, I think, very promising as we go forward.
And that could be very similar to the military systems in operation. That is, the device could have a camera and someone could be looking at it in real time, only not having to climb up to the top of the Tappan Zee Bridge or whatever it is.
Oh, absolutely. We did that with dam inspections. Really exciting. Really exciting. You know, working for the Tennessee Valley Authority, where we took and we had the engineer from TVA right there looking at the monitor while we're flying the drone. I hesitate to call them drones, but we're flying.
That's
this.
a terrible word.
It's terrible. We got to get that out of the lexicon. But anyway, we're flying it and we're looking at the dams and we're mapping the dam at the same time we're collecting data, collecting imagery. The engineer is looking at it and making on-site decisions with regard to what needs to be done with maintenance and those types of activities. So it's really promising.
And just a detail question on rail, because the rail infrastructure is aging in the United States. It's expensive, but it's also critical still. I've seen videos where someone just has a camera by the track because they're a train fan and watching a junction come apart as the train goes over it. And you can literally see bolts unworking themselves, and here's a disaster waiting to happen. And so getting back to that preventive area, can there be autonomous systems or unmanned systems that operate on the infrastructure itself? That is, could you send some kind of a vehicle with the right sensors and cameras down a track and look at it in that manner without needing a train or a crew to do it?
Sure, it can be done. I mean, the sensors, the technology is already here to be able to do that. It's the will and the wherewithal to be able to employ the technology. And there we'll probably talk about it a little bit, but there are some other restrictions just inherently in the United States airspace that we have to deal with that are very practical limitations.
Yeah, there's regulatory considerations
Yes.
that you have to take into account pretty much for all the media and modes of infrastructure.
That's right.
All right, and then there is climate change and environmental issues. We want to get to those too before we close today. And can drones, robotic systems work in this whole climate area, and what are we talking about for that? Because that gets very close to the energy infrastructure.
Yes, it does. Now, you know, what is most relevant in this climate discussion? It's measured change, right? And if you can't measure the change with accurate data, then you don't really know what it is you should be doing to be able to affect the change. And so where unmanned systems can come in, both in all domains, either air, land, and sea, can help you collect high quality data in terms of imagery or other aspects that can help you map and see and understand what's going on with regard to climate change. I had teams that worked up near the Arctic Circle, measuring ice flow melt, measuring the melt that's going on up there. We use multispectral technologies to be able to do that on certain air systems and operating in very demanding conditions. So these activities are ongoing, and the technology is certainly relevant to being able to help us in that area.
In this case, we're often talking about fixed sensors, correct?
When you say fixed, what do you mean by fixed sensors?
Fixed by location, that is something monitoring the area around it, or are we talking about motion types of devices, drones or not
we
drones,
can do both.
autonomous systems?
We can do both. You know, so you put the sensor on the aircraft and you're moving the aircraft around, so the aircraft is obviously in motion. You could put the sensor on some fixed portal. You could take the sensor and you could tether it to a vehicle, and you could have the sensor follow the vehicle where you need it to go and look at the various things that you need to observe.
Because what I'm getting at is there are two technical considerations in the sensor world that are important in this whole monitoring kind of area. One of those is the development of light encryption, because very often these sensors that are actually doing the measuring don't have a lot of processing power. And then there's the area of connectivity. They have to broadcast this information with low power, because there's not a lot of battery availability because of the size and weight considerations. And is that something you deal with and working on?
Well, it's something that we partner with companies that do that sort of thing, and that is something that's being worked. One of the things that has advanced so much over the last few years is miniaturization of the technology. When you miniaturize your sensor capability but keep the power at the same level, or the capacity to be able to sense at the same level or better than you had before, that requires less battery power on a battery-powered vehicle to be able to operate effectively for longer periods of time, which obviously makes it much more efficient.
And how does government and industry interrelate here? Because they have a common interest in looking at infrastructure, monitoring the environment, monitoring, say, around chemical facilities or whatever, for a variety of reasons, both the climate question itself, also regulatory concerns of EPA. It seems like there has to be a lot of parties involved in agreeing on how we'll do this, how we'll handle the data, and maybe even the technical standards employed for this kind of remote monitoring and autonomous monitoring.
I think that's sort of because, unmanned systems used to be sort of thought as that's a nice to have, but now unmanned systems are becoming more of an essential component of nearly everything that's done. So that means a lot of different government agencies are involved in the various activities associated with it, and the commercial entities that are doing everything from the R&D to full-scale employment and execution are engaged in and understanding how the government structure and the regulatory structure of that impacts the ability to be able to employ the technology effectively.
And autonomous vehicles, especially those that fly, are getting more sophisticated, the platforms. And they're also getting less expensive and therefore more accessible just to the general public. And do you run into the issue of people that shouldn't be looking at something but have the technical capability of looking at it and gathering data, and that could cloud the picture for people, let's say, who are officially checking on something?
Well, the hobbyist out there, the hobbyist has the rule, they have the rules that they're supposed to follow. But when you get into a professional enterprise, such that I've been involved in, then privacy laws, privacy data is taken very, very seriously. And so in your planning, when you do your planning, you look at analysis of alternatives, and you take that analysis of alternatives, and in that analysis is how do you preserve the privacy rights that affect any particular action or activity that might be ongoing. And that's going to require flight plans or sensor looks or even altitudes that the vehicle flies to be able to adhere. And also, in natural disasters, let's say you have a natural disaster, then, there has to be some impetus ahead of time just to let the public know that these systems will be flying, and this is why they're flying, and this is the data that they're collecting, and it has to do with getting their infrastructure back in place faster.
And one more question for the time we have left. What about the human capital requirements of this burgeoning type of approach to monitoring and looking at what's going on? Because you're dealing with, scientists and engineers that are probably totally comfortable with it, but you've also got the hard hat, blue collar work staff that is very experienced in the field, and you've kind of got to get them used to this new techniques and new technology. What are some of the human issues, human factor issues?
Well,
here?
the number one thing is it's not replacing. And that's the thing. It don't replace, but augment. So you see the importance, especially in the commercial sector. Many might think, hey, we're going to replace X number of personnel with this one system. But what we find over time is that it's more effective and more efficient when it augments and it works with that complement of people. And you can see that in bridge inspections, road inspections, those types of activities. And so that's probably the first thing that you need to think about as you employ these systems.
All right, some great thoughts here. Interesting discussion. Thanks for being with us. My guest today has been Tim Saffold. He's the Executive Vice President of Autonomous and Unmanned Systems for the Engineering, Science, and Technology Strategic Business at Amentum. And I'm Federal Drive host Tom Temin. For more on this discussion, please visit federalnewsnetwork.com and search Amentum.